So hey everyone, thank you for joining us today. So the game development is club at SGSU is introducing you to our Unity and Git and GitHub workshop. So first a little bit about myself. My name is Rafael Padilla Perez. I'm a junior majoring in software engineering at SGSU. I'm the president of the game development club at SGSU, and I'm currently working in a game called Taka Taka, which is soon coming to Steam. Shameless plug. This is me right here at GDC with one of my heroes, Mark Brown. It was so cool to meet him. There are my socials. If you guys want to reach out and connect, I would be happy to help you in whichever way I can. Yeah, so let's kick this off. So this is today's agenda. This is what we'll be covering. So first we'll talk about what is Unity, going a bit of an introduction, overview, how you do visuals, programming, sound, all the aspects of a game. Then we'll talk about Git and GitHub and collaboration with it. So we'll do an intro, how to use Git, GitHub, because they're two different things. People think they're the same, but they're actually two different things. Then we'll do our setup for doing a GitHub repository with Unity, because it's kind of like a fiddly setup you gotta do. And then just a quick note, our recording will be available after all of this session for you guys to see. I think Anuj will be helping us out with that. And also all of the code and assets that I'm going to be writing today, the finished project is going to be available for download in each page I prepared as well. So let's get started with Unity. Unity, so what is Unity? So Unity, it's a game engine. What the hell is a game engine? So it covers things like rendering, physics, sound, input, everything a game needs to work in just one solid cohesive space. No need to do it separately in pieces, etc. It just has a great suite of tools to cover everything you need for a game. Unity specifically has some really good compatibility. It supports web builds, so you can put your game on the web in a website like those Flash games we played when we were kids, basically that, but with something called WebGL. So I highly recommend you put your games in a web build online, because specifically for game jams, people can just play with one click. They don't have to download any files, anything like that. So just one click and boom, I'm inside the game and I'm playing. And you can do that in itch.io, which is great. Unity supports also Windows, Mac OS, and Linux, also consoles like the PlayStation, Xbox, and then mobile devices like iOS, Android. And I recently got my game working on the Steam Deck as well, so Unity is great for all of that. And also another plus for Unity, they have a great community and great resources for learning it. I highly suggest you check a channel on YouTube called Rakis, also check out GameMaker's Toolkit, which is this guy I just showed you, Mark Brown. Really great channel about game design. He also has some great Unity tutorials. And then there's also Code Monkey, which is more focused in Unity and programming and so forth. So I wanted to quickly show you what the full project that we'll be working on today looks like. So let me maximize this on the screen. So this is what the finished game would be looking like. It's kind of bare bones, but it's not a complete game yet. It's just meant to be a way for you to get started, learn Unity, learn programming, and make your first jam game. If you were to participate in a game jam like the one that's going to happen this weekend, you could expect to finish something of this scope and size. So this is what the game looks like. So you are a little astronaut, and then you shoot the little aliens with your ray gun. Then you can see score goes up in the top left. You have a really nice cursor, and we can also have some objects on the map, etc. So a really simple game, just meant to get you in the vibe with Unity. And then you can explore more with this. You can add more levels, more types of enemies. You can make the game restart whenever you kill a certain amount of enemies, add enemy spawners, etc. So it's just meant as a starting point, and all the files for this will be available for you to play with. So once that we saw that, let me go back here in the slides. Yeah, let's start talking about the Unity Hub. So the Unity Hub is what you download when you want to use Unity. And the nice thing about this was recently implemented, is it allows you to manage your projects in like the physical files in your computer, and as well lets you manage the versions of Unity. Unity is an engine that gets updated almost weekly or bi-weekly, I would say. It's really fast-paced, so it's a great way to manage which version your game is running in. You can upgrade your game to a new version, downgrade it to a previous version, and so on. And you can also manage information about your account. So let me show you quickly what it looks like, and then how you can make your own project from scratch. So you can see I made this huge green mouse, so hopefully it's easier to see things on the screen. So if we were to make a new project, you could just download this, make sure you have a version of Unity installed. So I have version 2021.3.8. I think we're on version 2022 point something right now. Just download what's the latest, I would say, or whatever your team is working with. And then we will click on new project. And here you've got a bunch of options. So for today's example, we're going to be making a 2D core game. So essentially the core you need for a 2D game. Here you can name it. So you can name it Spaceman, whatever. And then here's the path where you're gonna store this game. I'm not gonna go through this process because it can take some time, 5 to 10 minutes. But I have an example game prepared, which is a demo of that game that I have already open. So when you open Unity, you're going to get something like this. You're going to get a bare bones project. So once we went through the Unity Hub and how that works, let's go a bit deeper and talk more about Unity. So this might be a little bit daunting at first. There's a bunch of annotations everywhere, but I hope to guide you around with my mouse. So here on the left, we have what we call a hierarchy. So you can think of this as a hierarchy of something called game objects. So just think of each one of these as an object in your game, and the hierarchy, how does those objects are organized in your game. Then in the bottom, we have the project explorer, where you have all of the files of your project, and you have a scenes folder where you have the scenes for your game. Don't worry if I don't go too much in depth. I will further go in depth in other slides. Then we have here on the right what we call a component in this little rectangle. So a component is something, a property you add to the game object. That could be physics, that could be a transform in this case, etc. And we have this whole section right here is called the inspector. So just some lingo that you should memorize so you can talk to others about this. So the hierarchy on the left, you also have the project explorer, you have the inspector. In the inspector, you have components. This menu pops up when you select an object. You can see this one is highlighted in blue. So I'm selecting this object. And in the middle, you have the juice. You have two tabs. You can see the scene view and the game view. The scene view is where you manipulate things and move them around in your game so that you can lay out what your game looks like. And then the game view is what the player is going to actually play. Like after you build a game and publish it somewhere, if you go here in the game view and press play, that's what your player is going to see. So it's great for testing. And in the top, you can see three little buttons. So there's the play button, the pause button, and the next frame button. So if you press play, the game is going to run, obviously. Then you can play pause to stop the game when running. And you can click this button that is for next frame, the one which has the little arrow, and that makes you go frame by frame. So say you want to analyze how an animation works, you can just use that button for that purpose. So now let's go a bit more in depth into all of these panels and what they do. So starting off with the hierarchy that I was talking about, let's talk about first about what is a game object. I like to think of it like as a game thing. So this can be a player, a tree, I don't know, the ground, any object that you can build up to make your game. And then in these game things, in this game objects, you add properties, which we call components. So components could be like a renderer if you want to render something, an audio source if you want this object to emit audio. You can add physics if you want this object to have gravity and interact with colliders. And you can add a script so that you can play with this object. And then we have, as a whole, we have the hierarchy, which is where we organize our game objects. So you can organize and name them. It's really important to stay organized in Unity because things can get out of hand really, really fast. So you're going to have a game object called your player. Maybe your player has, I don't know, a baby that he carries around. So you can name that a child. And it has this structure of parent-child. So as you can see here in the bullet points, it's kind of like bullet points, essentially. So you have a parent, and then you have nested within this parent a bunch of children. And then those children are going to follow the parent. Then on the bottom, we were talking about the Project Explorer. So going back for reference, all of this section is the Project Explorer. So here's where you're going to organize all of your game files. So your sprites, your audio, your music, your sounds, animations, all of that. You can organize it in files and folders. And there is a folder here you can see called assets. This folder is one-on-one with your computer. So if like in your Windows Explorer, you just drag and drop something to the assets folder, it's going to show up here inside Unity, which is actually really neat. And then you can drag and drop files from your Explorer, Windows or binder in macOS into this Project Explorer, and it's going to do it automatically. I will demo in a little bit. And then you can modify a couple files by selecting here. For example, if you want to change the resolution of PNG and so forth, which we will do in a little bit. And now let's talk about scenes. So here in the Project Explorer, by default, you're going to have a folder that says scenes. So scenes you can think of as basically the parts of your game, how you can break it in different parts. So that can be the different menus. So you can have a scene called main menu, a scene called game over menu, and then a scene is full of game objects. So you can have a main menu that has a button, which, for example, in a main menu, you have a play button, maybe you would have a quit button, but then let's say you want a game over menu. So you create a new scene and you could do like replay, high score, etc. It's basically groups of game objects in specific scenes. So let's go ahead and try making some scenes so that I can demonstrate this. So let me go inside let me close this Unity, which is the other project. And let's go inside here. So this is the demo. I was talking here about the assets folder, and here we have the scenes folder. So the way you create things in Unity is usually right click and then just create. So here we see a bunch of options. Let's get started by looking for scene over here. We also have a sample scene by default. So I'm going to save Unity. Always remember, press Command S or Control S every like 5 seconds. You don't want to lose any of your progress. And I'm just going to rename this sample scene to, let's name it game. Then we can reload. And you can see that we are now named game. Let's try creating a new scene. So right click, you go to create, and then we can go to scene. And then you can name this game over and so forth. So what I was telling is that you have different game objects for every scene. So for example, in our game scene, we probably want, I'm going to be creating here. So right click, I'm going to be creating an empty object. I'm not going to put anything on it. And I'm just going to call it player, for example. Now, if I were to double click in game over, so first of all, save, always remember to save. And if we go to the game over screen, you see that that object is gone because it's not a part of the scene. So we can create, I don't know, game over menu, right? And then Command S to save, Control S to save, and then we can move back and forth. And you see that these are basically two different slices of your game. You can use this for making different levels, for making different screens for user interface, and so forth. So that's a little bit about how the scene system works in Unity. Let me take a quick sip. All right, sprites and animations. So the visuals. In 3D, you would have 3D meshes, but in 2D, we work with 2D objects called sprites. So a sprite is just a 2D graphic object, which is used for gameplay. And then an animation is the sequence of sprites. So you guys might recognize something like this, which is from Mega Man. This is what we call a sprite sheet. So what you would do is you would have basically in the 80s, 90s, where memory was really limited, they wanted to have one image and then slice it into smaller images. That was faster than loading many images from memory. So what they would do is create these things called sprite sheets, which are super convenient for the game, and we'll go into further on. And these are the sprites for the game. So an animation is just a sequence of sprites that plays on a loop whenever you press a button and so forth. And the way you create sprites in Unity is you drag and drop an image, a PNG, a JPG, and then you make it called a sprite. So I'm going to be posting here in the Discord, I don't know if right now or after, over here. So these are the files we'll be using for today. So if you click download in this folder right here, that's going to download everything for you from the itch page. I might as well just post it in general in case any of you guys are following right now. There we go. Yeah, you can download those files. So now that we have those files, let me delete that game over scene. We won't be doing it with that. So you can just use delete or command backspace if you're in a Mac. And let's create a new folder. So right click, create folder, and let's call it sprites. We're going to be bringing our game sprites in here. So now that I downloaded that, it's going to be a zip file. So we can just unzip that. We're going to see the files. And here we have our sprites, the sprites we're going to be working with. So let's open this folder. Let's open all of these. So let me just drag and drop over here to Unity. Like I was saying, Unity literally supports dragging and dropping things. So I'm gonna drag and drop all of this into this sprites folder right here. So let me close that. And you can see it's now here in Unity. Then you might also see this folder called Piscale files. So in order to make all of these assets, if you would like to get started with pixel art and working with that, I highly recommend this app called Piscale. It is free. You can use it in the web and you can download it. And if you want to play with the files I have here, you can just edit those out. So now we have all of these, and you can see when we imported them here on the right in the inspector, it says that they're sprites to the UI. So that is great. We now have our files inside of Unity. So there is a problem though with working with 8-bit art, which is we want it to be crisp. We want it to look nice. So why don't we go ahead and start by working with sprite sheets. Let's play with our player. So we have here the player idle animation. Let me zoom in so this is kind of easier to see. So you see there is a player idle animation. An idle animation is when you want a character to move around. So let's say I drop my controller, right, and I'm not paying attention. I want to know that the game is still running. I want to make sure that it's not frozen. So you just make your character do something random or funny, like go up and down or something like that. So this is a sprite sheet like I was talking about. This is not a single sprite, it's two. So we're gonna go ahead and cut them into multiple sprites. So you see in the top right, there is a setting that says sprite mode. We're going to set that from single to multiple because we have multiple sprites. Now that we did that, we can just click apply over here in the bottom to apply our changes. And then we can go to the sprite editor. And that's going to open up this window. Here is the thing though. You might notice the sprite does not look crisp. It looks like washed out. The colors change a little bit. And this is due to something called compression that computers do to manage file efficiency. So we want to remove compression to make sure our sprites look nice. So we go here in compression. You can say it says normal quality. Let's just set this to none. We don't really want any compression because our files are already really small. We don't want to compress them even more. And our astronaut looks really crisp. So now we need to slice this into a specific size. So we're looking at in the presentation, we had a little Mega Man. So the designer is going to create frames in a specific size, 10 by 10 pixels, 20 by 20. In this case, I made them 16 by 16. So we can go on the top in the slice option, then on type, we can go grid by cell size. So this is a pixel size you want to slice with, and then just change it to 16 by 16. And you can see these red boxes very nicely cut our object. So we just click on slice, and then we go here and click on apply, and we're done. Now we have individual frames from a single image, which is going to be great for memory usage and for optimization. So now that we have those changes, let me quickly look. Yeah, so let's go ahead and drag and drop this inside of the game. Let's drag and drop the frame 1 of our idle. And by the way, that is incredibly tiny. So let's play with this option in the top right, which says transform. So this is basically the coordinates, rotation, and scale of any object in Unity. And we're gonna change the scale to something like, I don't know, maybe 10 by 10. And oh my god, this looks so blurry. Why is this looking so ugly? Well, this happens because Unity applies filters to your 2D drawings. Unity is assuming that you have like a super high res drawing and wants it to look nice. So it applies this filter. So what we're gonna do is click in here in our object, in our file, the PNG file, and you can see there is something that says filter mode. So it's applying a bilinear filter. You can also apply a trilinear filter, but in this case, we want no filter. We want just the clean pixel art little rectangles. So we're gonna click here in point, no filter, hit apply, and now it looks amazing, super crisp. Our astronaut is looking great. So that is a bit of the pipeline you might want to use if you're using sprites with pixel art in your game. You might need to change the settings if you do something different, but that's a little bit about that. So now that we work with sprites, we have our sprites inside Unity. Let's look into the transform component I was talking about. So every single game object in your game has this component. It doesn't matter if you want to have an empty game object that like works with some code or plays a sound. It's always going to have a position in space no matter what. So this has 3 different properties. So we have the position, which is X, Y, Z in 3D space. If you were to do a 2D game, you would only use X and Y, so the X and Y coordinates. Then you have rotation, which is Euler angles. Euler angles are basically the traditional angles we learn in school. So 0 to 360 degrees, but in the X, Y, and Z axis as well. And then we have the scale, which is how big it is in the X, Y, and Z coordinates, which is it. We just made our player a bit larger, for example. So now we can go a little bit into the physics of Unity. So Unity has a really nice system to simulate physics. It can already do things like simulate gravity. It can do collisions. So let's make use of that. So let's first talk about rigid bodies. Rigid bodies are basically a property that makes any object in your game, any game object, interact with physics, interact with gravity, have a velocity, an acceleration, have collisions, etc. Um, and then we also have another thing called colliders. Colliders let objects with rigid bodies and colliders collide with each other, like they will happen in the real world. So if you're making a platformer like Mario Bros, then you're gonna have your ground have colliders and your player have a different collider. And they can be used in code to detect specific collisions. So for example, you want to detect if a bullet hits an enemy, then you want to kill that enemy, like in the aliens game we're working on. Or you might want to use triggers as well. Triggers are colliders that actually don't collide. They're only there to detect. So for example, with a checkpoint, right? With a checkpoint flag in Mario Bros. You don't want to actually collide with the flag and like bump into it. You just want to be like, okay, did the player touch the flag or no? So that's when you would use the trigger. And we have all sorts of 2D and 3D shapes to choose from in Unity for your colliders. Let me turn off my heater because I'm burning over here. There we go. Kind of cold here in the Bay Area. Yeah, we have all sorts of 2D and 3D shapes for your objects. So let's set up physics and collision for the player we just got into Unity. So I'm gonna go back to the engine. I'm gonna click here in our player. Then let me go to scenes. Make sure that I'm in the, let's go to the game scene. Yeah, I'm just gonna copy and paste. Another nice thing, you can copy and paste things between scenes, which takes a lot of work out from you. So we have the player over here, right here. Okay. Oh, it's this one, player idle. So let's bring our player idle over here. There we go. And there's a little astronaut. Naming conventions are huge in Unity as well, so that you don't get confused. So I'm just gonna rename this by pressing Enter because I'm in a Mac, or you can do right-click, rename, or Control R on Windows, and I'm just gonna rename this to player because this is gonna be our player. And then let's add the rigid body and the collider that we were talking about. So we're gonna hit here, Add Components. Just type rigid body in the search bar, and there are two types, 2D and rigid body. We're working in 2D, so let's add a 2D rigid body. So let's kick it off with that. Let's see what happens so far. So I'm gonna go into the game view by clicking up over here, and I'm just gonna go ahead and press play, and let's see what happens. So we can see that our player is now affected by gravity. He can fall. He's being tracked in the physics of the engine. But our problem is he's gonna fall to infinity if we just let this happen. So let's try just adding a small platform underneath the player to see what happens. I'm gonna go here to our hierarchy. I'm gonna right click, create a 2D object, sprites, and a square. Unity has a nice square that you can use for stuff. I'm gonna scale this, put it underneath the player. And this is basically a sprite. It doesn't do anything. So if I hit play, then we can see what happens. Our player just goes through this platform. There is no point. So like I was saying, if you want things to collide, you need to add a collider for both objects colliding. So we're gonna click here in Add Components, and then look in the search bar for a collider. We're going to be using, for this specific scenario, I think we're fine with a box collider. So let's click in there. Let's go to our scene view, and let's zoom in. By the way, in order to navigate the scene view, what you do is you use the scroll wheel to zoom in and out. Then you can use your right click in order to move around. And that's kind of it, honestly. So we can go here to our player, and we can see that the collider is now added as a property. So let's click on Edit Collider, and that's gonna let us change the bounce of this player. So let's make the collider a bit like closer to him, just like so. Let's do the same with the platform, which is called square by default. I'm going to rename it to platform, which is much nicer. Okay, and now let's add a collider to the platform as well. Box collider, and boom, we can click edit, and you can see that it wraps perfectly around here. So now that our objects have colliders, let's go to our game view, let's hit play, and then let's just see what happens. So now our player collides. So our player can collide with things. We can also, for fun, just grab him over here, move him around, and we can see that he collides with stuff. He can fall around, and so forth. Great. Now we have physics on our game, which is a great step moving forward. Um, let's go back to the slides. And moving forward, okay, now let's play a little bit with audio. I know there was an audio workshop before this, so if you guys have any sounds from there, it'll be a great opportunity. So we have two things in Unity that are used for audio, two components. One is called the audio listener, which lets our player listen to the music, of course, from various sources inside the scene. There is one on your main camera by default. If you add more than one audio listener, Unity is gonna get super angry and scream at you, so don't do that. And an audio source is just the source of audio inside your game. If you were making a 3D game, you would have a player talking here and a player talking there. So if you want to make like 3D audio that is like with a position, you would use that, or in 2D as well. So you can ask questions like when working with an audio source, things like where does your audio come from? What audio should we play? Which specific, like a laser sound or a jumping sound? And then specific ways you want to play this audio. You can change the volume, you can change the pitch, you can change priority, so make some sounds louder than others. For example, you might want sound effects to be loud, but footsteps while you're talking, while your player is talking with dialogue, you may want to have footsteps be like a bit lower in priority, so you can work with that. So I just got a looping main theme that we can add to the game, so you can see what it would look like. So let's go back to our game, and I'm just going to create a new object, and I'm just going to call it audio, just like so. So like I was saying, really nice way to get organized is to create objects for specific purposes. So we have our player and we have an object called audio, which is just empty. It doesn't have anything. And we're going to be adding our audio source, just like so. Real quick, I just want to make sure that our sound is running and everything. So I believe I need to do an application share in order for that to work. So I'm gonna quickly stop streaming, if that's okay. And then I'm gonna do application. And then gonna share the game. Okay. Okay, awesome. So now we should be screen sharing the game. So can you guys see the game still okay? Can you guys see Unity and everything? Just double checking. Okay. So let's bring in to Unity that cool sound loop we had. I'm going to go to my downloads folder and download that. This might be able to be made available to you guys after, or you can just use any sound. So I'm gonna click play. Please let me know if you guys can hear this. Can you guys hear this in Discord?
Yes.
Okay, awesome. So we're ready to rock and roll. So now we're going to go to our audio object, and then it is as easy as just dragging and dropping the audio clip you want to play. In this case, I'm gonna turn on loop because we want this game loop to loop essentially. And then if we go ahead and click play, the
Some
audio
of
should
us
play.
can't hear the audio, by the way.
Oh, you cannot hear it?
Some of us can't.
Oh, okay. Let's try again. Can you guys hear that?
Can't hear it on my end.
You can't. Okay. It's fine though. It's the same process. So yeah, if you guys were to add your audio, you would just do this. Unfortunately, we don't get the audio right now. But yeah, you just drag and drop over there, and that's it. So you make sure you click play on awake and loop, and then you should be able to hear the audio in your game. So now we're done with audio. Let's move forward into yeah, we can now move into Git. Wait a second though. Yeah, I think it's gonna be better if we do a little bit of programming before working with Git, so that we can just get our feet wet on that. So I'm just gonna change a little bit the order of the slides before. So we got audio, programming, console, and movement. Okay, yeah, sorry about that. Okay, so let's go into programming now. So let's make stuff happen in our game before we go into Git and GitHub. So Unity uses a programming language called, oh, by the way, I think I'm not screen sharing the entire screen now. Let me double check. Let's do this. Okay, now I should be screen sharing the entire screen. Can you guys see all of this? Just double checking. Thumbs up. Yes? Okay. Oh, I just saw this. There's like little bubbles over there. That's awesome. I didn't know that happened. I was like, why are you guys not typing? Okay, awesome. So now into programming. So Unity uses C Sharp, which is a high level language. It's not that deep like C, C++, or machine language or assembly. And it's object oriented in the way that you can access, for example, to access HP, you would do player.hp or game.gamespeed and so forth, which is really convenient. If you add a script to an object, you guys remember we were adding an audio listener or an audio source. If you add a script like that, it's going to run whenever you hit play. So that is how you run scripts in Unity in your objects. And then we have three types of functions in any C# script. So you have a start function, an update function, and the fixed update function. Start function runs once whenever you turn on the game, basically for one frame. Then update function, which runs every single frame that your game runs, and fixed update, which runs every X like real world seconds. This is set in the editor by default. For example, every 10 milliseconds, this part of the code is gonna run. Or update function runs every single frame. But computers move at different speeds. Maybe you have like a freaking 4090 that is blazing fast. Then it's going to be very fast. But you don't want our movement speed to be very fast. You want it to be consistent among players. So please, any physics you add to your code, make sure to add it in fixed update. That's going to save you a lot of headaches. So this is what it looks like. And then I'm going to show you the code itself in a little bit. So just like an overall view. And then this is the console. So what the console does is it lets you see what your code is doing. If you want to debug, which debug means basically fixing the code. So there are three types of things you can see on the console. So the first one is a log. So you can see here it's this little warning sign. Not a warning, like a little bubble. Then you have the warning, which is basically your code could be having a problem, but it can still run. It's not like a critical problem that is going to break the game, but still something worth looking at. And then you have an error that completely stops your game and it doesn't let it run at all. So those are the three types. And then you have the console here where you can see all of these things printed out in the screen. And then you have a clear console button. So if it gets filled and you're looking for something specific, you can hit the clear button. So while we get started, now we know a little bit about code and we know a little about the console. So let's write some code and let's see how we do it. How is the pipeline inside Unity? By the way, I made a mistake here. I'm being really disorganized. So let me create a folder and I'm going to call it music. And we put the music inside of there. Really important to be organized. Then I'm going to create a new folder and I'm going to call it scripts here in the project explorer. Then we're going to open that and I'm going to right click, create, and a C# script, which is the code. I'm going to name this player controller because we're going to use this to control the player later on, right after we do the hello world. And if you double click that and you installed everything correctly with Unity by default, you should open a program called Visual Studio, which is an IDE, which is an application where you can edit the code. So Let's see if it's opening up. Usually takes a couple seconds. Yeah, there we go. Oh, it opened in my second screen. There we go. Okay, so no thank you, no updates. Okay, there we go. This is what it looks like. This is what the code looks like. So we were talking about the start function, the update function. Then we also talked about the fixed update function. So let me add that so we can see how it looks. Looks something like that. So let's do our hello world for Unity. So doing a print in Unity is as easy as just typing print, opening and closing parentheses, and then every single line of code in C# ends with a colon like that, or semicolon, sorry. And then inside the print, we're going to put the quotation marks. Quotation marks means that something is a string, and a string is just a word. So our computer is reading this as a word, and it's gonna print it. So here we're gonna do, I'm gonna type hello SGDA, and then save this file. And then we're gonna go back in Unity. So let's hit play and see what happens. Are we gonna see anything? Let's look at our console. There is nothing. What is going on? And by the way, it's saying that there are no audio listeners in the scene. So I think I did this by accident. Your camera comes by default with an audio listener. So let's add that just in case. So yeah, you can see Unity gets angry if you don't do things correctly. So let's add that. And yeah, the music is playing, everything is fine, but we don't see our message. How are you gonna be able to see our message? Well, we didn't add the code to any object, so that's why the code is not running at all. So the easiest way to add it is literally clicking on our player. You can drag and drop here in the inspector in this side, or you can drag and drop in the player directly. So let me go ahead and drag and drop into the player, just like so. Okay, and now we see our player. Now he has the script player controller here within its components in the inspector. So let's hit save. Let's open up our console that we were talking about, and let's hit play and let's see what happens. So we see the message hello SGDA, which is awesome. So now that we did that, let's try to get our player moving so that we can move in the screen. Let's do a quick tweak though. So our background is kind of blue and our player is supposed to be in the moon or in space. So what we can do is click on the main camera, and then you see there is something that says clear flags. Make sure this is set to solid color. We want a solid color background. You can add an image or anything else. And we can just change the color to something we like. I'm gonna make it like more spacey, like the very, very dark blue kind of. There we go. So let's save, Control S. I'm also gonna get rid of the platform because this is gonna be a top-down shooter. So again, whatever genre your game is, you're going to be having different approaches on how you do things. And now let's move our player around. Let's try to get him moving. So we already have a rigid body, which is great. We also have a box collider, but we're making a top-down shooter. And if we want it to be top-down, we don't really want our player to fall down with gravity because we're supposed to be looking at from the top and gravity is acting like that. And then our plane is moving on this axis. So what we're gonna do is we're going to go to a rigid body 2D, and we're going to see here that there is an option that says gravity scale, which is set to 1. What you can do is change the gravity. So let's see what happens if we made it 10, right? If we made it 10, the gravity is now more intense. And our player is basically for like 2 frames on screen. It falls super fast. But if we make it 0, just like so, and then save, we can see that now our player doesn't fall at all, which is great. We don't want him to fall by the effects of gravity. Now that we have that, let's go back into our code, into our player controller. And as we know, games are different from movies in the sense that in a game, you have input, and input does things. In a movie, you just see a video. So we're going to need to listen for input from the player. So in order to do that, we're going to need to add some variables. So let's add one called private, which means it can only be seen in this code. So in this script, only can be accessed here, this variable. So private, then we're going to be making it an integer, which is written as int. Or actually, let's make it a floating point number, like that. So floating point means basically a decimal with a point. And let's call it x-axis, just like so. And we're also going to create a second one. private, float, and let's call it y-axis like that. As well as I was saying, you end every single line with a semicolon. And now let's put something inside these variables. Let's make something actually happen. So here in our update function, I was talking about how in update it runs every frame, but fixed update runs every x seconds, every x real world seconds. So what we're going to do is in update, we're going to be listening for input, so keyboard strokes, mouse, and then on fixed update, we're actually going to do the physics, do the actual movement. So we're going to do x-axis equals input dot get axis, which I think is, yeah, get axis raw. And then we're going to do horizontal. That is a lot of code, but let me walk you through it. So our x-axis, then we have the equals. So whatever is in the right side, which is input.getAxis, is going to be put into the left side, which is this variable. So what Unity is doing is from the input system, get the axis and get the raw data of that axis, which axis? The horizontal axis. So in Unity, you can set axes for things. So horizontal, vertical. By default, Unity does horizontal, which with the A and D keys for you gamers out here, or with the left and right arrow keys, which is great. And we're going to repeat the process with the y-axis. Y-axis equals input.getAxis raw. And instead of horizontal, now we're going to do vertical. Then we add a semicolon, and then we save. But now let's say we want to see this. We want to see what is actually being calculated. So let's make a print. Let's make a new print. But this is why prints are useful, because you cannot actually see the code, but you can see text generated from the code. So we're going to do add a string. So this is going to be like x, and then we're going to add. This is a concept called concatenation. So you can add text to numbers, which sounds kind of weird, but you can basically concatenate, add text to each other. If I have the letter A and then B, and I add them, that is basically putting them together. That is what concatenation means. So we can add x-axis, then we can add a space, then we can add a text that says y, then we can add another space, and then we can add the y-axis, like this. So this is basically going to print a number. By the way, this is how you do a comment. Comments are great for documenting your code and letting other people read it and know what's going on. So you add 2 slashes, and then any text you write here, Unity is not going to care. It's not going to run it. It's just for you to use and document stuff. So this is what our print is going to look like. So print is going to look like x, then colon, and then like a number, I don't know, 27, then a space, which is this space we added right here, space, then we're going to have y colon, which is this y and colon here, and then we add a space, which is this one, and the y-axis number. So it's going to be like 30 something, right? So we're going to save this, and now let's go in Unity, and let's see what the hell happens. So we hit play, and we see that our x is 0 and our y is 0. But let me try pressing the arrow keys in the keyboard. So you can see if I press the right arrow key, x is now 1, which is the positive axis. I'm going to let go, and it's going to go back to 0. Now let me do the left. Now it's -1, and if I let go, it's going to be 0 again. Let's do the top arrow key. So that's going to be 1, and then the bottom arrow key, that's going to be -1. So those are kind of our different movement directions. So this number is going to tell us where we're moving. Where do we want to move? If 1 is right and -1 is left, if 1 is up and then -1 is down in those directions, we can now use those numbers to change the velocity of our player and make him move in different directions. Let me do a quick check over here to see that everything's okay. Okay, everything's okay. So yeah, let's go back into Unity and let's keep working on our script. So now we have our axes. We can do cool stuff with this. So let's go to our start. And I was talking about components in Unity. You have a rigid body component, you have a box collider component, a transform component. And the cool thing is all of these can be changed via code. You can literally change their values by using code. So you see that we have a bunch of settings here for a player. In the rigid body 2D, we have material, we have position, rotation, velocity. So let's change our velocity so that we can move. So in fixed update, let's make first a variable. So I'm gonna call it private. Let's make it type. We can make it vector 3. So vector 3 is a point. So an x, y, and z coordinates. Really simple. And let's call it movement. And then here in fixed update, we're going to set our player's velocity to this movement vector that we just created. But in order to do that, we need to actually get the rigid body. So we need another variable that I'm gonna call so that it's private, only accessible in this code. It's going to be a rigid body 2D, and I'm just gonna call it RV for the sake of simplicity. And then in the start function, so when the game plays, we're going to do RB equals get component, and which component is going to be a rigid body, just like so, and a rigid body 2D, let's not forget. Then you open and close parentheses and add a semicolon. So this is saying, okay, Unity, get me a component. The component is going to be a rigid body 2D, and then put it inside this variable called RB. So now we have all of that. So let's try doing something. Let's go here in our update function, and let's set our movement vector. So movement equals new vector 3. So we're telling Unity, okay, create a new vector 3 and put it inside this variable called movement. And this is going to take 3 arguments that are separated by commas, because we have an x, a y, and a z, as you can see here. So our x is going to be our x-axis that we just worked with. Our y is going to be on our y-axis. And then z is going to be 0. We are in 2D space, so there is no reason we should move in the z-axis. So we're just going to set that to 0. Now that we have our movement vector, let's do this. Let's do our RB dot velocity equals and then movement. So what this is going to do is change our velocity in the x and y axis that we got. So if x-axis is 1, which means we're pressing to the right, then our velocity in x is going to be 1, which means our object is going to move to the right or to the left, up, down, and so forth. So let's try going back to Unity, and let's just give this a shot and then see what happens. So our player is now moving with the left and right arrow keys and the up and down arrow keys. But not gonna lie, I think this guy is kind of small. Slow, and this would be quite boring. So another nice thing of Unity is you can access variables inside code by making them public. So I'm gonna do public floating point, and then I'm just gonna call it move speed. So a public variable of type floating point number, a decimal called move speed. And now if we go back in Unity, you see there is this field, which is really cool, called move speed, and it's set to 0. Let's set it to something crazy like 10 to make our player faster. And let's go back to the code. And now we're going to be multiplying this movement vector by this velocity. So times move speed. What this is going to do is our x, which is going to be -1, 0, 1, times this move speed, which is going to make it faster. So now we can save that. We can go ahead and hit play. And let's give it a shot. And our player is now way faster than before, which is nice. So I don't think I'm going to go more in depth with physics because we have other things to cover from the engine. But that's a little bit about programming and physics in Unity as well as the console. Okay, so going back in the slides, we made our player move now with the script player controller.cs. Here's the rigid body. We changed his velocity. And now let's talk about Git and GitHub, which is super important for collaboration, especially in game jams. So Git is a version control system to have versions of your game. We know how Unity has different versions, 2021, 2022. You do that, but with your games. You're probably seeing games that do like alpha, beta, gamma, delta, epsilon, whatever for the versions. It tracks changed files in what we call a repository. A repository is just a bunch of files in your computer. That's literally what a repository is. And then it lets you create versions. And for example, why is it useful to have versions of your project? What if you make a big oopsie and everything explodes? you might want to go back, or maybe your computer explodes and then you want to go back to a previous version of a project. So that's why. Git is usually used with a command line. So the terminal, like in Mac. So if I open up a terminal, it looks something like this. And then you will write commands on the terminal. There we go. So something like this, and then people will type commands here, which is like a bit more complicated and in depth. I highly encourage you to learn Git to the command line if you're a programmer. But for now, let's use some other tools. And this happens locally. Git happens locally in your computer in the host. There is nothing in the cloud yet. This is literally like a way to organize your files in a disk. That's it. There are 3 things you can do with a Git repository. So pull is basically pull the changes any of your teammates make and have them now locally. But this is done through GitHub, which we will talk about in a little bit. Then you can commit. So committing is adding a file to the repository. So I made a change. I am happy with this change. Then I can commit it, right? And then after committing, you push, which is pushing that commit into the repository. Committing is just like saying, okay, it's done. So now what? Pushing is like, okay, let's push it into the repository. So that's Git. Git is for local version control. But we want powerful tools to work in the cloud with other people. We want to share files. We want to share what we're working on. Maybe I'm working on the levels. My friend is working on the level controller, player controller, and so forth. So that's why you use GitHub. So GitHub lets you store a Git repository in the cloud. So you can work with other people, collaborate. And I'm going to show you a quick example of a GitHub repository that I worked on. So for example, there is this repository I worked on. This is what it would look like. So this is a repository I made with the Game Development Club. I taught them how to make Super Mario 64 by scratch in 3D, which was super fun. And I walked them through the process of modeling, painting, rigging, weight painting, animation, programming. And then we made this kind of a fun clone of Super Mario 64. So this is what a repository looks like. So you have all of your files over here. Then you have what is called a README file, which we will talk about in a little bit, which is like an explanation of what this repository is. And then you have a .gitignore, which is super important. I will talk about in a little bit as well. So that's what a repository looks like when publicly available. So how in the heavens do we create a GitHub repository? So after you have an account, you just go to github.com, create your account. Then you want to create a new repository. So in order to do that, you just hit this green button that says new, and then it's going to create by default a README file and a gitignore file. So a README file is just information, like I was talking about in the Super Mario Bros. Example. And then a gitignore makes it so that Git doesn't track any files you don't want to track. So when Unity works, it generates kind of like files that are not important, like binary files and stuff like that. You don't want to actually have your teammates download because they're kind of useless, honestly. They're useful in your local machine, or for example, you have heard about cookies when navigating the web. Why would you want to push your cookies to your friends? Like there's no reason to that. So that's why we use a gitignore. So let's create a new repo and let's try making some commits with this repository from scratch. So in order to do that, we just go to github.com. Like I was saying, I'm going to go here to the home page. So you should see something like this. We just go ahead and click new. And I'm going to name this repository something like Spaceman Demo. Then you can add a description. Woo! Then you can make it public or private. I suggest you make it private if you don't want people to see your game yet, but I suggest you also do public because you want to show this off to recruiters, to people in the industry. So it's nice to have something to share. Make sure you add a README file if you want to add any information. And then it says something about adding a gitignore that we were talking about. So this is really nice. They just did this, but you can find the templates for gitignores here. So you can just go here and select Unity, which is nice. Just one click and you can see the gitignore template there. Then if you want to choose a specific license, there are a bunch. I think they have, MIT license, etc. This is kind of for the license if you want to share this intellectual property or not. That is honestly up to you. And then after that, we can just hit the create repository button and we will basically be done. So now there is this repository. where we can share files with our friends and work. So how do we add other people in our team to work with us in this project? You go here to the settings, clicking on the gear, and then you will go to collaborators. And basically you need to log in, go through that process, and that's going to let you add their GitHub account so they can work with you. So this is kind of step one. We're now set to work with this. Step two is going to be uploading the files from our computer to this repository so that they get tracked. So you're going to be downloading. I highly suggest you use this just for ease of use. If you want to learn the terminal, that is awesome. I highly encourage that. But there's also this tool called GitHub Desktop, which is kind of a more UI friendly version of GitHub that you can work with. So you can download that for here. And it's going to look something like this once you download the GitHub Desktop. Let me maximize it so it's easier to see. So over here, we're going to go here and then click on add, which is going to add a new repository. And we're going to click clone. What does cloning mean? Cloning means download the files from the internet into your computer. So in order to do that, we're going to be using a URL. So let's go here to our Spaceman demo. Let's just copy our URL. Let's go here, add clone repository, and then we just put the URL here and clone. So that's going to download the files that we have into our computer. So that's it, Spaceman demo. So now it cloned the files from the internet to your computer, and they are now in a folder in your specific computer. So what we're going to do is right click here, and we're going to go to Reveal in Finder. So this is going to show us specifically where it is. So we have a README, which is what we have right now over here. And the git ignore is going to be hidden, but don't worry about that. It's going to show up still here. Now we have this folder, but we want to start tracking our files. We want our teammates to download these files and use them as well. So let's go to our Unity Explorer over here, and we have our Spaceman demo. Let me show it in the Finder as well to see where we are at. And we have all of this. So why don't we try dragging and dropping this into the folder to Spaceman demo right here. And now let's see what happened. We added all of our files into Spaceman demo, which is linked to the repository. And then if we go back here, you're going to see that things have now exploded. Now we added a bunch of stuff. We added all of our game files. So more than 20,000 game files. So in order to commit this for your team members to use it, you need to add a summary. So I'm going to call this like initial push. And then I'm just going to click here and commit to main like that. But we're getting this error, which is that our file size is way too large. So what this can tell us is that maybe our git ignore is not working. So this is not on tracking files that we shouldn't track. It's tracking things like these binary files, artifacts, etc. So something is not working here. In order to fix this, let me quickly get out the command over here. Okay, so this might be the only time you need to actually run this in the terminal in your computer. So we can do this, I think. Yeah, so repository, you can just open it in the terminal directly. This is kind of like the single command you need to make these things work. So all we need to do right here is add this command, which is git rm -- cached, I believe. Yeah. And then I think we could just add the asterisk or the dot. Give me a sec. Now git rm. Oh yeah, recursive cached and then dot. Okay. Let's go back here. Okay. This is kind of odd. This shouldn't be happening. But don't worry, I'll be posting like a how-to in order to make the git ignore work. This is problem number one that I found in all the game jams I have participated in. There's always problems with the git ignore not tracking the files correctly. But I'll be like sending an addendum after this meeting, so you guys can get that fixed if you encounter this problem, which is super common. But it shouldn't happen, which is the crazy thing. But it can happen from time to time. So that's a bit about how git ignore works. And yeah, honestly, I think we're just out of time from what we covered today. So once again, here are my socials. If you would like to connect or anything like that, if you had any questions, hit me up on Twitter, hit me up on Discord. And I hope this workshop was helpful to you all. I kind of speed ran through it to make sure we got it done in an hour. I think we actually are right in the hour, so that is great. Yeah, does anyone have any questions or anything I can help with? All right then. So I guess we'll be posting a video from this later in case any of y'all need it. And all the game files will be there. You could try out the completed game. Yeah, I hope this was useful to y'all.